morning, ma'am. This is K. Sainam from first year, Department of Computer Science and Engineering. Now I'm here to give a presentation to find the minimum value of x square plus y square plus z square given that xyz which is equals to a cube. Firstly, Lagrange's method of undetermined multipliers. Suppose it is required to find the extremum for the condition f of xyz subject to phi of xyz which is equals to 0. Let us consider this as first equation and process for finding the extremum value for a function. Step 1. From the Lagrange's function f of xyz which is equals to f of xyz plus lambda into phi of xyz, where lambda is called Lagrange's multiplier which is determined by the following conditions. Step 2. Obtain the equations dou f by dou x equals to 0, that is dou f by dou x plus lambda into dou phi by dou x equals to 0. This is equation 2. Dou f by dou y equals to 0, that is dou f by dou y plus lambda into dou phi by dou y equals to 0. This is equation 3. Dou f by dou z equals to 0, that is dou f by dou z plus lambda into dou phi by dou z equals to 0. This is equation 4. Step 3. Solve the equations 1, 2, 3 and 4 which gives the stationary values of x, y and z. And note, to find the maxima or minima for a function f of x, y, z equals to 0, subject to the condition phi of x, y, z which is equals to 0 and psi of x, y, z equals to 0, form the Lagrange's function as f of x, y, z which is equals to f of x, y, z plus lambda phi of x, y, z plus mu into psi of x, y, z, where mu and lambda are the Lagrange's multipliers, and proceed as the above. And here comes the problem. Let f of x, y, z equals to x square plus y square plus z square, which is considered as equation 1, and phi of x, y, z which is equals to x, y, z minus a cube, considered as equation 2. By Lagrange's method of multipliers, f of x, y, z which is equals to f of x, y, z plus lambda into phi of x, y, z which is equals to x square plus y square plus z square plus lambda into x, y, z minus a cube, and dou f by dou x equals to 0, whereas dou f by dou x equals to 2x plus lambda into yz equals to 0 and 2x plus lambda yz equals to 0, whereas lambda yz equals to minus 2x, lambda equals to minus 2x by yz, and whereas lambda by minus 2 equals to x by yz, and dou f by dou y equals to 0. Dou f by dou y equals to 2y plus lambda into xz equals to 0, whereas 2y plus lambda xz equals to 0, lambda xz equals to minus 2y, lambda by minus 2 equals to y by xz. This is considered as equation 4. And dou f by dou z equals to 0, dou f by dou z equals to 2z plus lambda into xy which is equals to 0, 2z plus lambda xy equals to 0, lambda xy equals to minus 2z, lambda by minus 2 equals to z by xy. This is considered as equation 5. And from equations 3 and 4, x by yz equals to y by xz, whereas x square equals to y square, x equals to y. This is considered as equation 6. From equations 4 and 5, y by xz equals to z by xy, z square equals to y square, whereas z equals to y. This is considered as equation 7. From equation 6 and 7, x is equals to y is equals to and z. And given that xyz is equals to a cube, whereas we concluded that x is equals to y is equals to a. From equation 1, x square plus y square plus z square which is equals to a square plus a square plus a square, that is 3a square. F has a minimum value is 3a square. And conclusion. In conclusion, the equation x square plus y square plus z square with the constraint x, y, z equals to a cube establishes a relationship between the sum of squares of the three variables and their product. This constraint limits the possible values of x, y, and z, and depending on the symmetry or a specific assumptions about the variables, the sum x square plus y square plus z square can be optimized or evaluated. While the sum represents a geometric representation from the origin, the constant xyz, which is equal to a cube, restricts the set of solutions, making it possible to derive the specific values or further analyze the relationship using techniques like optimization or symmetry. Thank you, ma'am.